All right, hello, Math 13 students. I'm sending along another supplemental lecture. This time we're going to talk about testing claims about a population mean. We're going to test claims using the t-test tool and the TI-84, and then we're going to find a p-value or two using the t-CDF tool. So let's go ahead and get going. 8.3, claims about a population mean. Let's be clear we understand what's going on. We're going to use X bar to test a claim about mu. There are some requirements. We need a simple random sample, and then either or a sample size greater than 30 or a population that follows a normal distribution. So those are the requirements. There's only two of them, but they are important. They're people requirements. Your calculator really has no clue if you got a simple random sample or if the population follows a normal distribution or not. Only the researcher does. There is a test statistic involved. We may be asked to find that from time to time. It's pretty straightforward. I'll point out again, as I've done before in the past, it contains stuff from our sample and it contains detail from the null hypothesis. And again, in some sense, it's a quote unquote simple fraction. As far as a tool goes, we'll use t-test with a p-value approach to test claims about mu. If we have a standalone problem involving a p-value, we're going to use the t-CDF function, very much like the normal CDF function. And we'll do that when we need to find the p-value for a given test statistic. So let's take a look at a couple of examples. The first one, we claim that the mean number of units per semester at Hartnell is more than 9.5 units. We have a random sample with a mean of 10.4 units, standard deviation of 3.1, and a sample size of n equals 40. So I will note that we have the randomness required, and we have a sample size greater than 30. So we meet the requirements for constructing or conducting a test of hypothesis. Now let's take a look at that test of hypothesis. It's about the mean, so there's my mu. And the claim is that that mean is more than 9.5. So mu greater than 9.5, that there is destined to be the alternative hypothesis. I'll use that to generate the null and the alternative. You've seen me do this a number of times now. So H naught mu is equal to 9.5 units, and the alternative mu is greater than 9.5 units per semester. We're going to use an alpha of 0.05 or 5%. That's my level of significance. So, first thing for me to do is to get things started. So I've got my data there, my alpha. The only thing I don't have is the claim. So the 5 steps, H naught, mu equals 9.5 units, and H1, mu is greater than 9.5 units. I'll remember that this is my initial claim. We'll address that at the very end of the process. Now, what I'll want to do is I'll want to go ahead and share my screen. We'll take a look at this on our calculator. Get rid of all that stuff. So step over to test. We have a t-test here. We're going to select that. I have summary statistics. The claim is that the mean is equal to 9.5. So 9.5 goes in. Sample mean 10.4. Standard deviation 3.1. Sample size 40. We have a right tail test. And we'll go ahead and calculate that. And there's my p-value. There's the test statistic, there's the p-value, 0.03698. So that 8 makes this 9 a 0, so 0.0370. So p equals 0.0370. 3 significant digits. It's a probability. The calculator's done its job. There's my p-value, 0.0370. 0.05 was the level of significance. My p-value is less than the level of significance, so we will reject the null hypothesis. That means we're going to go with the alternative, which is our initial claim. So at alpha equals 5%, data support mu greater than 9.5 units. All right. And those are the 1, 2, 3, 4, 5 steps for your average everyday test of hypothesis. Now, what are some of the subtleties here? Well, this test can be done with raw data. I don't need my summary data. I don't need X bar S or N. I just need sample data and some detail. So we have a claim that the mean commute time is 40 minutes. And we're going to assume that we have a normal distribution for time. And that'll enable us to use this random sample. So this should say random sample. So because it is random, and because we're going to assume a normal distribution, that enables us to go ahead and conduct the test with some confidence. All right. Mean commute time is equal to 40 minutes. I see equals in that claim, so we have the null hypothesis. Mu equals 40 minutes, and then the alternative mu is, well, the converse to equals is not equals 40 minutes. So those are my claims. Top one is my initial claim. We're going to go ahead, get the problem started, and then I'll jump over to my calculator and we'll go through the keystrokes. So first step. Here's my claim. Now, let me come over here, share my screen again. And I'll go right to edit. I'll clear out a list. I'll usually use list one if it's available. And we have, let's see, 33, 49, 37. 65, 54, 41. 30, 20, 70. 45, 45, 40. So data sets rarely get larger than this on quizzes and exams. It really needs to be about the question, not about getting a bunch of numbers in there accurately. So we've got that in there pretty good, I think. And we're now ready to go over to stat. I select my t-test again, but this time I use data. We had a claim of 40 minutes for my commute time. Data is in list 1. If it wasn't already selected, I could certainly point it there. Frequency should stay at 1 here. We have a two-tailed test. I'll make sure I select that, otherwise I'll get things wrong. And now I'll calculate the p-value. So there's my p-value, 0.3398, 0.340. With 3 significant digits, 340. Let me stop my sharing. So there's my p-value. %, that was my alpha. So it's really clear that the p-value is bigger than the alpha. So the outcome is to fail to reject H0. So that was my initial claim. So we failed to reject it. So we're going to keep H0 as our working hypothesis. So we're going to say at 10%, level of significance, data, support, mu equals 40 minutes. You could also say alpha equals 10% or alpha equals 0.10. But here again, you got to count them out. 1, 2, 3, 4, 5. So they always have 5 steps. That's the way they always look. So there we go. Now I'm going to finish up this discussion with a example of finding a p-value from a given test statistic. So we need a claim, find a p-value, and we need a test statistic. Actually, all we need is the type of test, left, right, or two-tailed test. So when I take a look at this, I take a look and I see the mu greater than for this particular claim. And that tells me I have a right tail test. Again, I think a quick picture really helps things. We have the t distribution. So we're going to go up the hill. We're going to go down the hill. That's t there. Zeros in the middle, just like z. We have a test statistic of 2.94. And it is this area in there, this guy right here, that is our p-value. So there is where the p-value lives. It is an area. And to find it, I will need the degree of freedom because it is a t distribution. So that's 50 minus 1, or 49. I need the t cumulative distribution function. So that's what I'll go ahead and use. I'm going to bring you back to my calculator. Clear that out. Second, distribution, T CDF. The lower limit, 2.94. Upper limit, 10 raised to the 9th power. Degree of freedom, it's 49. You know, I can actually put in 50 minus 1 if I'm afraid I might get that wrong. Haha. So let me go ahead and paste that in. Hit enter. and I get a 0.02498, 3 significant digits, 0.00250. So let me go ahead and stop my share and note that that area there, 0.00250, that is the p-value right there. So my p-value in this particular problem, 0.00250. And there we go. Now remember, if you're going to be asked to find the p-value, usually these problems specifically come with a claim and a test statistic provided. It's usually found in the context of a test like we've been doing, but sometimes they appear in standalone form. Anyway, there we go. I'll thank you for your time, and I'm going to stop my recording. Do be well.